Hello everybody. So in this video, I'm going to be discussing central limit theorem using Rguroo, which is basically just an extension of the last video, which was on normal distribution in Rguroo. So I'm going to go ahead and do the PowerPoint here first. And then we'll go to Rguroo and do all the examples. All right, so first of all, let me take a minute and talk about the central limit theorem. So our central limit theorem tells us what our distribution of sample means looks like. So when we're talking about sample means, we're dealing with central limit theorem. So the central limit theorem says that the distribution of the sample means is normally distributed, and actually I have this on the previous slide, that is normally distributed with a mean that's the same as the population mean, and a standard deviation that's the population standard deviation divided by the square root of the sample size, and is normally distributed with that mean and standard deviation as long as your sample size is greater than or equal to 30 or your underlying population is normally distributed. So basically, we know that the distribution of the sample means is normally distributed. All you have to do is change the standard deviation. So this is going to be very similar to what we did with the normal distribution. So here's the first example we're going to do. Assume the ages of people at a company are normally distributed with a mean of 47 and a standard deviation of 5. We draw a sample of size 15. So since the underlying population is normally distributed, we know our distribution of the sample means is also normally distributed with a mean of 47, and your standard deviation is going to be 5 over the square root of 15. And we're going to answer all of these questions here using Rguroo. So let me go ahead to Rguroo now. And so the other additional step that we have to do here is we have to get our standard deviation, because it will not take it as 5 over the square root of 15. We have to get a decimal. So to do that, I'm going to go under the Apples tab and the Desmos Scientific Calculator, and I'm going to get my standard deviation from here so I can type it in on the probability tab. So I'm going to do 5 over square root of 15, which gets me 1.290994449. Now I'm not going to round that. I'm going to keep that as is. And now I'm going to go to the probability tab, probability, continuous. So we're going to use the exact same functions here. We're going to use normal because it's still normally distributed. Our mean is going to be 47, and our standard deviation is going to be 1.290994449. Now the first question that we're asked is, find the probability of the sample mean age being between 30 and 35. So I'm looking for a probability, so I'm on the correct button here. So I'm going to put between 30 and 35, hit the eyeball, and there's my probability, it's 0. All right, now the next question, find the probability of the mean age of sample being more than 50. So I can just go under here and edit and put above 50, hit the eyeball, and I'm going to get 0.01. And then the next question, I want to know the probability of the mean age of sample being no more than 45. So that's going to be below 45. Hit the eyeball. I'm going to get 0.061. And now the next question asks me for the 65th percentile. So that means I have 65% of the data below my data value. I'm now looking for a data value. So I'm going to switch here. I'm going to put a lower tail of 0.65. Hit the eyeball. And I get a data value of 47.5. The next question asks me the minimum sample mean age in the top 8% of the sample means. So that means that I have 8% above my data value. So I'm going to have an upper tail of 0.08. That gets me 48.81. And then the last question asks for the middle 50%. So if I have the middle 50%, that means I have 25% on each of the edges, the remaining 50% divided in half. So I'm going to put between tails, and then my two tails are 0.25. And then hit the eyeball. And I'm getting my middle 50% being between 46.13 and 47.87. All right, so that's our first example. We're going to do 3 more examples. So let me stop my share here and go to the PowerPoint to show you the second example. All right, so this is going to be our second example. So note we drew a sample of size 50 from the town. So even though this doesn't say it's normally distributed, it's still okay, still meets the central limit theorem conditions. All right, so we're going to answer all of these questions here using our Rguroo. So our mean is going to be 67, and our standard deviation is going to be 3.5 divided by the square root of 50, since we're talking about sample means. All right, let's go to our Rguroo now. So the first thing I need to do is get that standard deviation. So I'm going to go back to my scientific calculator here. So if I want another row, I can just hit enter. I need 3.5 divided by square root of 50. So that gives me 0.49, 497, etc. So we're going to type that whole number in for our standard deviation. Back here now, so I'm going to go under basics because we can just edit it. So our mean was 67. And then our standard deviation was that long decimal, 0.4949747,468. And then the first question I'm asked for the probability of the mean height of the sample being at least 70. So I need to switch back to the tab that calculates probability instead of calculating data values. I'm going to put above 70. And then I'm going to hit the eyeball. And that gets me a really tiny number. So that's, remember, that's the e negative 10 means times 10 to the negative 10. So that looks like this. It's, I'll type it over here, 0.000000000. I think that's the right number. Yes, 6767. So that's basically 0. So count 10 to the left from where we started. So that's basically 0. The next one, I'm asked for the probability of the sample mean height being between 65 and 68. Oops, let me get off of this here. So I'm going to go under basics, and then I'm asked for between 65 and 68. So I got 0.9783. The next one, I'm asked for probability of sample mean height being less than 66. So I'm going to put here below 66, hit the eyeball, 0.022. And now the next question I'm asked, find the sample mean height in which 35% of the sample mean heights are shorter than it. So that means if 35% of my data is shorter than the data value I'm looking for, it's lower. So I have a lower tail of 0.35. So let me switch over to the probability value since we're searching for a data value now. Lower tail of 0.35. That gets me 66.81. The next one, the middle 34% of the sample mean heights. So if I have 34% in the middle, that means that I have, so my remaining amount is 66% divided across the two edges. So 66 divided by 2 is 33. So I have 34 in the middle and 33% on each of my edges. So that means I'm going to put between tails, and it's going to be 0.33 for both. So that means my middle 34% is between 66.78 and 67.72. And then the last one, I'm asked to find the sample mean height in which 22.5% of the sample means are taller than it. So if 22.5% is taller than my data value I'm looking for, that means it's an upper tail of 0.225. Since taller means higher data values. Hit the eyeball, and I get 67.37. All right, that's that example. We're going to do two more. All right, our next example is this example here. So we have the running times of people at a high school. So it's normally distributed. So we know we're good with the central limit theorem, even though our sample size is less than 30. So our mean is going to be 11.2. Our standard deviation is going to be 0.15 over the square root of 20. And we're going to answer all of these questions. And remember, percent just means probability. If you want to convert it to a percentage, you can multiply it by 100. But we'll just look at what Rguroo is giving us right now. All right, so I'm going to stop my share and I'm going to go to Rguroo. All right, let's get our standard deviation as a decimal first. So that's going to be 0.15 divided by square root of 20, which gives me 0.0333541, etc. So that's going to be our standard deviation. So now our mean was 11.2. And that was our standard deviation. So I'm going to type that in. All right, and now the first question I'm asked for, the percent of the sample mean times that exceed 11.5. So that means I'm going to put above 11.5. And I'm looking for a probability now, so I change back to this. Hit the eyeball, and I'm going to get, that's a really, really tiny number, right? That's going to have 18 zeros and then the 1872. So that's definitely 0. And then the next one, I'm asked for the percent of the sample mean times below 11.3. So I'm going to put below 11.3, the eyeball. I'm getting 0.9986. And then I'm asked for the percent of the sample mean times between 11.15 and 11.25. So I'm going to put between 11.15 and 11.25. That gives me 0.864. All right. Now, the next question I'm asked for is find the sample mean time that is slower than 29% of the sample mean times. So if it's slower than 29% of the sample mean times, that means it's a higher data value than that 29% because slower means higher times. So that means my 29% is going to actually be the lower tail here. So I'm going to have, let me switch over here because we're looking for a data value now. It's going to be a lower tail of 0.29. Hit the eyeball, and I get 11.18. Now the next one is kind of the opposite. It asks for the sample mean time that's faster than 58% of the sample mean times. So faster means the lower data value. So that means I have an upper tail this time of 0.58 because that 58% is above my data value. And then hit the eyeball, and I'm going to get 11.19. And the last one asks for the middle 95% of the sample means. So that means if I have 95% in the middle, I have 2.5% on each of the edges, the remaining 5% divided in half. So I'm going to put between tails, and I'm going to put 0.025 for both of them. Then I'm going to hit the eyeball. And I get between 11.13 and 11.27. All right, we're going to do one more example here, and then that'll be it for this section. All right, so the last example here. So we're going to do this example now. So we're going to answer all these questions. So we took a sample of 35 babies, so it doesn't matter that it's not normally distributed. Our sample size is greater than or equal to 30, so we're good to go. So we're going to answer all of these questions. So our mean is going to be 7.5, and our standard deviation is going to be 0.5 over the square root of 35, since we're talking about sample means. All right, so let's go ahead and go to Rguroo now. I'm going to start by getting that standard deviation. So 0.5 divided by square root of 35 gives me that long decimal that I'm going to put in for my standard deviation in the calculator. So our mean here was 7.5. And then I'm going to enter in that long standard deviation. All right, and then the first question is asking for a proportion. That's the same as probability. So I'm going to switch the buttons here. Find the proportion of the sample mean weights that are 8 ounces or more. So proportion means I'm finding a probability. That's why I have this selected. I'm going to put above 8 and then hit the eyeball. So that gets me this very tiny number. So remember, that means times 10 to the negative 9. So it's going to be 0.000. So it's going to be 8 zeros. And then the 1649. That's what happens when you move the decimal 9 places, to the left. So that's 0. Basically, when you see this e to the whatever, it means 0 in essence. And then the next one, I'm asked for the middle 23%. So now I'm looking for a data value. So let me change the button here. So if I have 23% in the middle, that means that I have 77% remaining to split over the two edges. 77 divided by 2 gets me 38.5. So I'm going to put between tails 0.385 and 0.385. Hit the eyeball, and I get that it's between 7.475 and 7.525. All right, and then the next one I'm asked for is the smallest sample mean weight in the top 3%. So once again, I'm looking for a data value. So I'm going to keep it here. And since I'm looking for the top 3%, that's an upper tail of 0.03. Hit the eyeball, and I'm going to get 7.659. The next one, I'm asked for the proportion of the sample mean weights between 7.6 and 7.7. So I'm going to go back to, I'm looking for probability again now. So, and then I'm going to put between 7.6 and 7.7. Hit the eyeball, and I get 0.1094. And then the next one, I'm asked for the proportion of the sample mean weights that are 7.4 or less. So that one's going to be below 7.4. Hit the eyeball, I get 0.1184. And then the last one, I'm asked for the highest sample mean weight in the bottom 30%. So once again, I'm looking for a data value here. So let me switch again. Bottom 30% is going to be a lower tail of 0.3. Hit the eyeball, and I get 7.456. And that's it. So that's all for central limit theorem. It's basically just a slight variation on the normal distribution section we did previously. If you have any questions about any of that, please feel free to reach out to me.